So once again, if you need to kind of move around a little bit, you can. Not once again the greatest room, but try to make it work. Okay, so this is chapter 5 here, and we're going to talk really about nomenclature and how to name everything. And we're going to focus in on here this kind of short part of the lecture, really on ionic nomenclature, which is what activity 10 is about for today, and the different types of ways to name those guys. And then we'll cover the rest of it, obviously, next time. First off, when we do talk about names, there are certain things that are just sort of go by their common names. And a couple of major ones for us is really these first three. But H2O is water. It's not a trick question or anything like that. It's not dihydrogen monoxide or anything like that. Nobody wants a refreshing glass of dihydrogen monoxide. You would like a glass of water. NH3 is ammonia, not to be confused with the polyatomic ion that we'll see later, which is ammonium and kind of sounds and looks very much like the same. CH4 is the simplest organic molecule you could have, which is methane, like stuff comes out of the gas. So I would say those three for sure. You should definitely go by those names. The last two here, I would say most people still call this sodium chloride, which is table salt and some table sugar. So water is water, H2O, NH3 is ammonia, and CH4 is methane. Now, when we talk about naming compounds, there's really two types of compounds that we're going to talk about, and it revolves around what we talked about in terms of bonding. The first type is really ionic compounds, which is what we're going to focus on here in this lecture. And ionic compounds are always between a metal and a non-metal. And it's always the metal that basically will transfer its electrons over to the non-metal. A result of that is we will create a cation from the metal that's positively charged and an anion from the non-metal, which is negatively charged. And once again, it is the attraction between those two, as we talked about with bonding, that holds that together. There's no sharing of electrons happening here at all. The other type of nomenclature we'll talk about is covalent molecules, or sometimes people call them molecular. And these are always between two nonmetals, and they're always sharing of electrons. And as we talked about with bonding, it may be equal sharing, maybe unequal sharing, but there's some aspect of sharing that is happening here. So depending on really what type of compound you have, you do follow some different sort of rules about how you go about naming them, depending on what's present and what is happening there. So let us first start about ionic compounds, really. So ionic compounds are sometimes broken apart into two different sort of categories, either type 1 or type 2. So type 1 and type 2 refer to ionic compounds. And when we have ionic compounds, as I mentioned, it really is a cation and anion that's present. So we should talk about how we go about naming just ions by themselves. So if you have just the ion by itself, you know, sort of the process that we go by in terms of naming them. And let's do it up here so you can see. So for example, if we have something that's H plus or something that's Na plus or Ca2 plus, once again, as we talked about, we pretty much just use the whole name here. So once again, this would be the hydrogen ion. This would be the sodium ion. This would be the calcium ion. So a couple things on this. If you were to draw the formula, these would be the formulas for these cations, and they should include the charges because they are ions. So the charges should be included whenever you write a formula for an ion. Now, anions, on the other hand, are named a little bit different. So anions like H minus, for example, or O2 minus, or Cl minus. They basically take the first part of the name and then they get basically the IDE treatment at the end of it, as I think we might have talked about in a previous end of a previous chapter. So this would be hydride ion. Oxygen becomes the oxide ion. Chlorine becomes the chloride IDE ion. Once again, these are the formulas for the anions, and they should have the charges associated with them. So whenever you write formulas for ions, they should always include the charge. Positive ions, just the name of the element, basically. And negative ions basically get the IDE at the end of it. A reminder that when we do put anything that's ionic together, whenever we put a positive guy together with a negative guy, it needs to equal 0, the charge. So once again, if we had our calcium plus our F minus, when we put these guys together, we need one more of the F minus, and that would give us a -2 to balance out the +2. And the proper formula would be CaF2. Once again here, the overall compound, when you put the positive negative guy together, it should have no charge, but it is made up of obviously 3 things with charges. The calcium has a +2 charge, and 2 fluorides each have a -1 charge. The reason for this is what we talked about with bonding. When we put it together to equal 0, what we are essentially doing, like we talked about when we were talking about bonding, is allowing everybody to reach noble gas configuration. So if you remember when we kind of did the Lewis structures for this guy, we needed the extra fluorine to take the second electron from the calcium. And that's, again, the essential reason why when we put it together, it equals 0. It allows everybody to reach that noble gas configuration. Any questions on that there? Also, just a reminder as well from the periodic table, right? There are certain things that have fixed charges. Things in group 1 have a +1 charge. Things in group 2 have a +2 charge. Things in group 3, 4, 5, 6, 7, and 8. Group 3, which is mainly aluminum, has a +3 charge. Group 5, non-metals, -3, -2 for 6, -1 for 7. That's the non-metals above the staircase, right? Remember, our transition metals here can have multiple charges, except for zinc, cadmium, and silver. They have fixed charges. Zinc and cadmium are always +2, and silver is always +1. So those are 3 exceptions in the transition metal region that have fixed charges. Everybody else in the transition metal region can have variable charges, including to the right of the transition metal regions where we get things like lead, tin, all those guys, bismuth as well. They could have multiple types of charges. Any questions on that there? So what is the difference between a type 1 and a type 2 compound? The main difference is the metal, and pretty much these are, again, both ionic compounds. Means you always have a metal and a non-metal together. And once again, whenever there is a metal involved, that is the most important thing to look at. So it's always the metal that you should concentrate on when you're naming something. And if the metal falls in group 1, group 2, or group 3, so group 1, 2, or 3, or if it's zinc, cadmium, or silver, they basically all have fixed positive charges. And that would mean that it's a type 1 compound. If it's a type 2 ionic compound, it is the metal is a transition metal, or just to the right. Under the staircase. And they basically all have a variable charge. So for example, copper in certain cases could be +1. In other cases, it could be +2. Same thing with chromium, for example, it could be +2 or +3. Kind of depends on the situation. So whenever a metal's involved, that is always the thing that you should look at. It is always the thing that will allow you to sort of figure out, how you should go about naming it. The non-metal, not really important in terms of the naming part of it. It is really dominated by the metal being the most important. So here's a table similar to one you got in your book. Again, you can see all positive ions are just the names. All of our negative guys get the IDE treatment. And again, it is hydrogen that is kind of the only one that will go both ways, could be positive or negative. In most cases, hydrogen will be positive. It is usually negative if it comes after a metal. So if it's after a metal in the formula, hydrogen is most likely the negative version or the hydride version. Otherwise, hydrogen most likely will be a positive one. So let's take a look at the rules for sort of naming type 1 compounds. Type 1 compounds, metal and non-metal. Once again, our metal in fixed positive charge. So really all we do to name type 1 compounds is we use the whole name of the metal, and the non-metal gets the IDE treatment at the end. So we drop the last part of the non-metal name, lay in there the IDE treatment. So for example, our NaCl, when we look at this, first off, Na is a metal, Cl is a non-metal. It is the metal that's most important. So sodium is group 1, which means it has a fixed charge. So that means that's all you need. You would call this sodium whole name, and chlorine becomes chloride. If you had something like CaCl2, once again, you would look at that. Ca is a metal, Cl is a non-metal, so that tells you it's ionic. The Ca, which is group 2, tells you it has a fixed positive charge, and that makes it a type 1 compound, which means we call this calcium, and chlorine becomes chloride. So calcium chloride in this case. Now, when we look at this, it has no effect on the name. So there should be no prefixes. This is not dichloride or anything like that. It has no effect on the name. So this is just calcium chloride. The reason the 2 is there, again, is to balance out the charge. It's basically saying we have 1 calcium at +2 and 2 Cls at -1 each to balance out the charge. But it has no effect on the name. You could have 400 chlorines there and it would still just be called chloride. You could also have 200 calciums, by the way, there, and it would just be called calcium as well. So there is no place for prefixes here. Prefixes are used for something else, and this is not the place where you use them. So it's very common. People want to kind of put a prefix to make it sound more chemistry-like. Don't do that because it will be wrong in this case. Any questions on that there? Yeah. So a reminder that when we do see the formula for the ionic compound, it should always have a 0 charge when you put the cation and anion together. But it does represent 2 things that do have charges. So like the example on the bottom there, Ki, that's a metal, that's a non-metal. Once again, potassium is group 1, which tells us it's type 1. So once again, we just use the whole name there for potassium and iodide instead of iodine. This again, though, has no charge in this form, but it is made up of a cation that is K plus and an anion that is I minus. And those are 2 things, obviously, that do have charges. So in this case, this is how we get to the formula of Ki, because +1 and -1 equals 0. So we just need one of each of those to basically get to 0 in that case. Any questions on that there? All right, so why don't you try some here, and why don't we also do some names to formulas? So let's do magnesium chloride. Let's do some aluminum sulfide. Let's do Let's do some lithium nitride. All right, so proper names on the left, proper formulas there. Okay, let's take a look, see how we're doing. So K is a metal, Cl is a non-metal. So this tells us it's ionic. The potassium is the metal, which is the most important. That is group 1, which tells us it has a fixed charge. In this case, it would be K plus, and this guy, which is group 7, would be Cl minus, would be the anion. So really that's all we need. So we're going to use the whole name here. This is going to be potassium, and then the chlorine gets the chloride at the end of it. Any questions on that one there? Zinc is a metal. S is sulfur, which is a non-metal. Zinc is a transition metal, but zinc is actually one of those ones that does have a fixed charge. So zinc will be +2, and sulfide would be -2. So in this case, it is a type 1 compound because of that, and this would just be zinc sulfide, IDE, at the end of it. Any questions on that one there? Ca, which is calcium metal, Br, which is bromine non-metal. Once again, it is the metal that's most important. Calcium is group 2, which means it has a +2 charge. Br is group 7, which means it has a -1 charge. And in this particular case, because it's a type 1 compound, it's just going to be whole name here, calcium and bromide. Once again, the 2 here has no effect on the name. It would just be calcium bromide. Any questions on that one there? Lastly, here we have barium, which is a metal, hydrogen, which is a non-metal. So in this case, barium is group 2, which means it has a +2 charge. Because this is hydrogen that's coming after a metal, this is actually the negative version of hydrogen. So this is H-. That's why there's 2 of them, to balance out the charge. But it's really the metal that's most important. So barium, which is type 1, means that this should be barium. And then the hydrogen gets the hydride at the end. So barium hydride would be the name. Any questions on any of those names? Coming to the other side, we want to recognize what it is. So magnesium is a metal, chloride's a non-metal, so that's ionic. So we want just the basic units of this. Magnesium is group 2, which means we have Mg with a 2+. Chloride is group 6, 7, one of those 7, which is a -1 charge there. We need to put these 2 together to equal 0. So we need actually 1 more of the chlorides. So that gives us a -2 to balance out the +2. So putting that together would give us MgCl2 in this case. Any questions on that one? Aluminum is group 3, which means it has a +3 charge. Sulfide is group 6, has a -2 charge. So in this particular case here, we're putting together something with a +3 and a -2. Common number between those 2 is 6. Basically, just multiply them together. To get the aluminum to 6, we actually need 2 of them. So I'll just write up on top so you can see. And to get the sulfide to 6, we need 3 of them. So it would look something like that. Once again, that tells us we have 3 of these guys, each at -2, -2, -4, -6. And we have 2 aluminums, +3, and +3 is +6. So that equals 0 when it balances out. Any questions on that one there? Lastly, we have lithium nitride. I'll go to the top here so we can see it again. Easier. So lithium is group 1, which means it has a +1 charge. Nitride, which is a non-metal, is group 5, has a -3 charge. Once again, we need to put this together to equal 0. We actually need a few of the lithiums. We need 3 of them to balance it out. Gives us Li3N as the proper formula there. Any questions on that or type 1 naming? Again, type 1 naming, always ionic compounds, always metal, non-metal. always the metal most important. Group 1, group 2, 3, zinc, cadmium, or silver. They all have fixed charges, which means you just go whole name of metal, IDE for the non-metal. And if you have to put them together, you want to put them together in the simplest way that will get you to 0. Any questions on that there? All right, as promised, that's it.